Hi, everyone. Welcome to the fifth session of the introduction to the well intervention. We started the session, this fifth session we started last Sunday, but it was canceled due to some communication errors. So we are repeating the session again. We will have 45 minutes today talking about completion. So we'll finish at 6:15 Cairo local time, 45 hours. What we will discuss today is the will completion. And this word is too big to discuss it in 45 minutes, of course. We can talk about completion for 3 months continuously. But in this course, we'll have just general knowledge about the accessories we run with the completion, why we run accessories with completion, why the completion is not just a bare tubing all the way down and then we produce oil through it, why we have what we call SSD, SPM, landing nipple, ACAR, wireline entry guide, why we have these devices with the completion. So we have here to talk about general idea about completion. Why completion is part of well intervention? Knowledge. If you don't know the knowledge, you will do mistakes, definitely. So you have to have knowledge. People who work in slick line or completion or cold tubing, they have to know what's completion because they are running in the hole through these devices. So it is a must actually to know about it, definitely. We say that well completion is the hardware of the outflow system and the final stage of a drilled well. Once you drill a well, then you run the completion. This is the final stage. Then you are producing from this well. And the design philosophy of each completion we run, we have to have the maximize our profitability, which means that if there is 10 barrels in the reservoir, try to get these 10 barrels out. You might have a design that will allow you to get only 2 barrels and the remaining 8, you need to pay money of what we call secondary recovery or extra money for what we call tertiary recovery to get these 8 barrels out. If you look what I write here, by maximizing well hydrocarbon recovery and by considering the full hydrocarbon recycle life and without sacrificing the safety and environment, of course. I need you to know what we mean by premium thread. Because normally when we run completion or when we connect any two pieces together, we connect it sometimes through threads. We have what we call premium threads. This thread in my hand, we call it premium. This is MPT thread. MPT stands for National Pipe Thread. The MPT thread is the premium thread. Why? Because it is metal to metal seal. What makes the seal is the metal. We have some other threads, like Acme threads, we connected by our hand. We don't use a spanner to tighten because the thread doesn't make the seal. What makes the seal is this piece, is the O-ring. The O-ring is the device that makes the seal. Back to the premium thread like MPT, what makes the seal is the thread. That's why when we tie them together, male and female, what I'm doing is I'm using my hand to tighten. Then I have to bring a spanner to tighten with the spanner. because what makes the seal is the thread. And that's why it's very important. This is well intervention. This is well control. Is to check this thread from time to time. Because in the past, normally you connect and disconnect, connect and disconnect. So a little wear will happen to the thread. In the past, if this wear happens, that means you will have a leak. To prevent that, so we used to bring what we call Teflon tape. We go with Teflon tape around the thread. People used to put his hand in his pocket, get the whole packet of Teflon tape and 10 layers, 20 layers. This was a disaster, actually. So the API at that time said one single layer of Teflon tape to substitute this very little tiny wear that you cannot see it by your naked eyes. If you put this one layer and you connect, then use the spanner to tighten, pressure test. If still leaking, that means that the wear that happened to the thread is beyond repair. So what should you do is you disconnect it, kiss it, and say goodbye. Throw it in the garbage. And that's why this type of thread, you have to check it from time to time. So you have to go with a digital caliper. We have to measure the distance between each thread and the other. We have to measure the depth of each thread. And we collect these measurements and take it to the table of this thread. If it is within the margin, then this thread is okay. We do this for both male and female to be sure that the thread is in a good condition, because your life is here also. If you apply 3,000 psi and you die, simple as that. Let's go to the accessories we run in the completion. What we see here is a typical completion tubing, which is in yellow color. And you see these different colors, which is different accessories we tighten to the completion while running in the hole. Each piece of these accessories, we run it in the hole because it helps us to do a certain function that we need. We put these accessories into 5 groups based on the application we need it for. So for example, number 2, circulating device, for example. In this group, we put everything we use in the completion to do circulation or to create communication between a tubing and annulus. And since I have no idea, guys, if you have any idea about completion or not, but let me ask you this question. If I need to put a devices that we use in the completion to help us in circulating or communicating, what these devices are, do you know? Can I ask you this question and do I expect an answer from you? Someone say, cannot see the screen. I don't know how can I help you. Maybe Dr. Ahmed can. I cannot.
It is clear. It is clear.
Okay. Someone say, can you use English, please? Which means that I'm speaking French, looks like. I have these comments from another one. Dr. Ahmed, do I speak English, please? Advice?
Maybe because we were talking in Arabic at the beginning. Maybe
okay, before we start, maybe. Maybe. I'm still, okay, let me see if I have any answer to my questions. SSD, yes. Tubing, no. Tubing is not a device for communication. But SSD is. We will talk about the SSD now. You can run MPLT. MPLT is not, is a tools or is not for communication. This is to get data, to read pressure and temperature. It's memorized. SPM, yes, SPM, you are correct. SPM, side pocket mandrel, yes. Okay, let us continue on that. Yes, you are right. Then we have a device, a group, we call it isolation device, anti-erosion device, and the last group we call it others, where we put everything else that we cannot classify it into these groups. If you go back to these groups, first one is the anchoring device. The anchoring device is mainly landing nipples. The landing nipples we add to the completion. It is actually to receive what we call FCD, flow control devices. The flow control devices are mainly valves and plugs. The landing nipple is to receive that. That's why we call it anchoring device. If you look at this completion, you will see more than one landing nipple. It could be 2, 5, 8, 3, 1. I don't know. It depends on the design of this particular one. But any landing nipple we put in this completion is mainly to receive a flow control device, which is plugs and valves. You will see here that all of them are top no go, bottom no go. Don't be confused with the word no go. People sometimes confuse with word no go. That means no go for them means no pass. So if I put here on the top here, top no go, then nothing will pass. No. No go means no go shoulders. These no go shoulders in the landing nipple will allow all devices to run through except its own device. It will stop it, say, you are mine, you are not pass. Not all other pieces will pass. It depends on the size. It depends on the size of the tool you are running. So mainly, all landing nipples are devices to receive and flow control devices. It is true that we use them to correlate the depth. But if I ask you why you put landing nipple and your answer is to correlate the depths, you will get a big zero because this is not the purpose. She is doing that as a favor, yes, but it is not in her job description. In her job description, it is to receive a flow control device. This is the main job, the main task, the main mission. It is true that the last bottom one has more important mission, which is allowing us to isolate the reservoir from the lowest possible point where you put a plug. This will allow you to isolate your reservoir from the lowest possible point. This is an important in many issues actually, and I recall now while talking to you guys that during the war between Iraq and Iran last century, they reached the limit that Iraqi were hitting the Iranian fields offshore. So for the Iranian to protect their reservoirs, what they were doing, they were setting a plug, a wireline plug, deep in the well in this last nipple, and then put cement above it. So even if the Iraqi fighters hit this Christmas tree, the reservoir is isolated. The reservoir is safe with this plug and the column of cement above it. Circulating devices, we have two devices, yes. SSD stands for sliding side door, sliding sleeve, and SPM, side pocket mandrel. The isolation device, isolation means Parker. Parker is for isolation. If you look at this drawing, this schematic, you will see here we have top packer and we have bottom packer. Why we have two packers? We have two zones. This bottom packer, if you look at this bottom packer, what's below the bottom packer? Some pipes. The bottom packer, anything below packer, we call it bottom completion. Anything above a packer, we call it top completion. The top completion is hanged by what we call tubing hanger. This is the tubing hanger that hangs the top completion. What hangs the bottom completion? It is the packer. What's the bottom completion? Actually, the bottom completion is a couple of joints, having some accessories like wire and entry guide, a couple of landing nipple, maybe perforating joint, maybe permanent gauges. What hangs the bottom completion? It is the packer. Then I get you in the exam a question, what's the purpose of the packer? Then you select the answer saying to hang bottom completion. I'll give you a big 0 because she is doing that as a favor. It is not in her job description to do that. The packer is to isolate. Isolate what? Okay, this is the packer. Let's go to the packer. Here it is the packer. It isolates this area, all these annulus from the hydrocarbons that might affect the casing, or from the treating fluids you are pumping into the well, like acid, for example, entering these annulus, destroying your casing, upper casing. So El Packer is to isolate. We have some other device like tubing seal assembly, PBR. Maybe we'll have time to talk about that today. PBR stands for Polish bore receptacle. Polish bore receptacle. Then we have the fourth device, anti-erosion device. Anti-erosion device, we will talk about each one of that later on. The anti-erosion device, we have two devices mainly. We have blast joint, which is the blue color in the schematic here. This is the blast joint. What's a blast joint? It's a pop joint. It's a piece of pipe. But it has one advantage over the completion tubing. It has a thicker wall. Why? To withstand the hits that coming from the reservoir. Because if you look at this one, this blast joint, the blue colored pipe, it is exactly in front of the top completion, top perforation. So now we have hydrocarbons are flowing from the reservoir, getting into the pipe, into the completion with a velocity. It has sands. So these sand grains, it hits the tubing. It causes sandblasting. So the pipe will have holes in maybe 2-3 months, 6 months, 1 year. Then you have to kill the well, bring a workover rig, pull the completion, change this damaged part. And instead of causing you all these costs, so we run from the beginning this blast joint, which has heavy wall thickness. So it will withstand these hits. It will last longer. It will live, instead of 1 year, it might live 2, 3, 4 years. Sometimes we do it with the same thickness, but different material, like tungsten carbide or ceramic. This is the purpose of the blast joint. We have also what we call flow coupling. We will talk about it when we come to that. Other devices which we cannot classify it into these groups, like what? Like wireline entry guide, perforated joint, control line, tubing hanger. We will try in not 45 minutes, the remaining time of this course, to talk about each one quickly. Let's start with the landing nipple. First thing, landing nipple. What's landing nipple? Landing nipple. Landing nipple is the short pipe. It has 3 features: shoulder, seal bore, and profile. shoulder, seal bore, and profile. The purpose, we agreed to receive a flow control device, except last one. It is to isolate the reservoir from the lowest possible point. But as you see, it's a short pipe. It has 3 features: shoulder, seal bore, and profile. And all what we need to know in this course is why we use them and how we use them. Why we use them? To receive a flow control device. How we use them? Let us see how we use them. We use them, let's have a wireline plug, and we need to set it in the completion, and we need to set it in the last bottom completion here. So the wireline has the plug, and he starts running in the hole. While passing by all these devices, none of them will stop it because of size. Till it reached the last one that she would recognize this device. She said, "Stop, you are mine." Who will stop it? What device will stop? The shoulder. This is the reason why we have a shoulder. A shoulder is to locate or to guide or to enable a flow control device that you run to its matching profile. Because at the moment, the shoulder will stop the device, will stop the plug. The dogs, the mechanical dogs or Box Mandrel, which is spring-loaded dogs, will be exactly in front of the profile. This is the profile. This is the profile. This is the profile. So these dogs will be exactly in front of the profile, where the springs will push the dogs out to lock inside the profile and lock the device you are running in its place. So a shoulder is to locate, to guide, to enable flow control device to its matching profile. The purpose of the profile, with the help of the dogs, it locks the device in place. What's the remaining to do? It is to make the seal. What makes the seal is rubber. We call it elastomeric packing because this is the material we are using, elastomeric packing. This packing that seals within the seal bore or polished bore. This is the seal bore. Here it is. Or polish bore. This is the seal bore. Polish bore. Polish bore means that it has to be very smooth. If it is not smooth, it will not seal. Pressure will escape from these grooves you have. So it has to be smooth surface. This slide about downhole city valve, but I will not let you involve in this. This will take time to talk about. The second group, which is the circulating device group, we said we'll have 2 devices mainly. We have sliding side door and side pocket mandrel. What you see in front of you now is the sliding side door. Sliding side door. Let me see if you have any questions. Okay. Sliding side door. It's a pipe, short pipe. But as you see, if we cut it to see what's inside, you will see this brown door. This is sliding sleeve. Sliding door that moves up and down, sliding. If this door is closed, in closed position, if you notice there is some ports here. These ports are closed. So there is no communication between the tubing and annulus. If we need to establish communication between the tubing and annulus, what we do is we run with the wire line, we latch on this sliding door, and then we start jarring. Some design, you have to jar it down to open. Some other design, you jar it up to open. But regardless, the idea at the end is you move this door out of these ports. So these ports are open, so you start having communication between tubing to annulus or annulus to tubing. This is the purpose of the sliding sleeve or the sliding door. All what I need you to know in this course about sliding sleeve is 5 items. Number 1, why you use it? We use it for communication or circulation. Number 2, what should we do before we open it? What should we do before we open? Not just SSD, actually. What should you do before you open anything that has differential pressure across it? You have to equalize the pressure. Otherwise, you will have a problem. Yani, if you didn't equalize this SSD, you try to open it by force. If you are sitting on the rig floor on top and you open it by force with differential pressure, you will dance on the rig floor from this shaking of the rig. So you have to equalize the pressure between the tubing and annulus before you open. This is number 2. Number 3, when you open it, you have to be, it is fully open. Because if you move it partially, then you open the device partially. Then while circulating, this pressure of circulation will vibrate this door. This will affect the seal, the O-rings that we have to make the seal. If the O-ring is damaged, the device will not seal, will not close. And if it doesn't close, or it closes but leaks, it's a big issue. You have to kill the whale and pull the completion. It's no kidding yet. So number 1, it's for communication. Number 2, you have to equalize the pressure before you open it. Number 3, you have to be sure it is fully open. 2 remaining. Number 4, where we put it. Does any one of you guys know where we put the SSD in the completion? Let me see your answers on this question. Where you put the sliding size, sliding door in the completion. I have a question. Is it possible to have these PowerPoints? Yes, it is possible. I will send it on PDF to Dr. Ahmed, and I don't know if we can pass it to you guys or not. Yes, we can. I have no problem with that. Can a tubing perforated joint do you consider as a, this is the question I have from you guys. The question says, can a tubing perforated joint be considered as a circulation device? I don't know. Let us see. The perforated joint, you put it below the packer here. Actually, in this drawing, this is the perforating joint where the arrow is there. How you use it as a circulation device? You start pumping from the tubing. So pressure will come out of these ports in the perforated joints. Let us see here. And then you will have the packer. The packer will prevent this circulation. And also, if you pump from the annulus, you cannot reach this perforated joint because the packer will prevent you from continue. Then you cannot actually. I'm still waiting these answers to my question. Where we put the sliding door in the completion. So I have an answer here. Location between annulus and tubing, it should be position. One of the questions say it has to be a position. Let me go back. Position just above the packer. It's an excellent answer actually. We install them in the lower completion in the open hole. Wrong answer. The swelling packers are installed between HSSD for isolation. This doesn't answer my question. The question is just above the Packer. It is a perfect answer because people that said, look, here is the Packer. This yellow part above the Packer, this is the SSD. So people say, we put it above the Packer. I said, wrong answer. Why? Because if this is the Packer, here is, this position is above the Packer. If you put it near the surface, this is above the Packer. So people said, just above the Packer. Like your answer, right? Let me see. Use your expression, yani. You said just above the Packer, right? Wrong answer. Why wrong answer? If you put it, if this is the Packer and you put it just above the Packer, by time, the fluid in the annulus, where definitely you will have settlement of scales and debris on top of the Packer over time. If these scales accumulate on top of the Packer, then will make your SSD that you put just above the Packer stuck. You will not be able to open it. That's why we put the SSD one joint above the Packer. One joint means 30 feet above the Packer. So even if scales and debris accumulate on top of the Packer, you still have space. Still, the SSD is away. You can open and close the SSD. So we put it, remember, one joint above the Packer. In the completion in front of you, we have two Packers, right? Here is the top Packer, and this is the lower one. Why we have two Packers? Because we have two perforations, two formations. So since you have two Packers, then you will have two SSDs. One of them, you will put it one joint above the Packer, one joint above the top Packer. The other one, where you put it between the two Packers. Here it is. This is the second one, where we put it between the two Packers. But this one that we put between the two Packers is not for circulation or communication. It is for production. If you don't need to produce from the upper zone, keep it closed. If you need to produce from the upper zone, open it. So the one we put between the Packer is not for communication, but for production. The last thing I need you to know about the SSD, which is if in the design, I will use 3 SSDs in this one. These 3 SSDs, how I put them, I will use the top one to jar down to open, the other 2 jar close to open, jar down, jar up to open, or the first one jar up, the second one jar down, the third one jar up, or what? Away from the engineering, if we use the common sense, if I have 3 SSDs in the same completion, I will use all of them either jar up or jar down in one direction to avoid the confusion. What about the second one? It was jar up or jar down? I don't remember. Standardize your equipment. Either all of them jar up or all of them jar down. To summarize this in the next presentation and the next slides, these we use them for communication, equalize the pressure before opening, be sure it is fully open, set one joint above the Packer for communication or circulation or between the 2 Packers for production. Last thing I need you to know that all SSDs in the well has to jar in one direction to avoid mistakes. I'm just looking if there is any new question or not. Other device we use is what we call side pocket mandrel. What you see here in yellow color is a side pocket mandrel, which is a short pipe, but it has a belly. Where in this belly, we hide a valve here. We call it gas lift valve. We use this device in completion. We run in wells that is not self-flow. To flow from these wells, we have to use a secondary recovery. And the selection of the secondary recovery, which we select, is gas lift. But actually, sometimes we run these wells, we run these devices in natural flow wells. Why? Because we have a vision. We know from our study in this reservoir that this reservoir will be self-flowing for 6 months, 7 months. Then the well will be died, and we have to use artificial lift. So from day one, we run these devices, and instead of the valve we put in this belly, we put what we call a dummy valve. It's a plug. So these devices are not used while the period of self-flow. By the time we need artificial lift, we run our wire line to run what we call a device that kick-over tools that we move this dummy valve, remove it, and put gas lift valve to start using this device as a gas lift device. How many devices of these type of mandrels we'll have in a well? Is it 1, 2, 5, 6, 3? I don't know. It depends on the data you collect from the reservoir. Then you feed it to the computer, to the software, where it tells you that based on the data you give me, you have to have three side pocket mandrel in this one. First one, you will put at a depth of 2,520. The second one, we put it at 510. The third one, you will save it at 7,956. And these distances, these depths has to be very accurate, because these valves that you put inside these devices, it is a differential pressure valve that open and close at a certain differential pressure. So if by mistake, for example, you have the gas lift valve for side pocket mandrel number 1, and you run it, and you set it inside pocket mandrel number 2, this valve will not work. You set it at a different differential pressure, it will not work. He will not see this differential pressure. So it will not operate. So the depths has to be very accurate. When we have these devices, how to activate it? Normally, we inject gas in the annulus. This gas we inject from the annulus, it goes all the way through these ports. It enters the side mandrel, pass by this gas lift valve, where it has a check valve allowing this gas to move from annulus to tubing, but not vice versa, one direction. So these gas that you inject into the tubing, it lifts the column, the fluid column in the tubing to produce from that well. This is the purpose of the gas lift valve or the side pocket mandrel well. From where we get this gas that we inject? Good question. Normally, when you produce from a well, it's 3 phases. These hydrocarbons, it is water, gas, and oil. It goes through a separator where it separates these 3 fluids. And water, 1 most of the time we inject it back to the reservoir to increase the pressure and for more production. The oil, it goes to production line, to production facilities to see what we'll do with it. The remaining is the gas, where normally you burn it or you take it to such wells. Why we burn gas? Gas is energy. Why we burn energy? Although we buy it, although we suffer from Europe is suffering from gas reduction. Yes, why? Because it's not feasible. I mean, to get use of this gas, it will cost me more money than buying it is cheaper. Because to get use of this gas, I have to make a gas train. I have to convert this gas into liquid so I can transport it. So this gas, we take it there, we pump it in the annulus, then the cycle, as I told you. If you don't need to establish communication, what we put there is a dummy valve. It's a plug. If you need to inject chemical, for example, you remove this valve, the gas lift valve, and put chemical injection valve. If you decide to kill the well through this side Box Mandrel, please remove the gas lift valve and put what we call differential kill valve. All these valves, circulating valve, gas lift valve, chemical injection valve, differential kill valve, all these valves you put in the side Box Mandrel, all of them has a check valve that allows you to have this circulation in one direction only. Then people ask me, Ahmed, if this is the case, why don't you keep the gas lift valve and do whatever you like? Just circulate whatever chemical, whatever, killing the well. Why you change it and put another valve? To answer this question, I said, this is what we call gas lift valve. And please, put this in your mind. Any device that works with gas is expensive. So don't spoil it, don't destroy it. It is a very expensive piece. Use it only for the purpose of what it is designed for. Who told you, for example, that if you need to pump chemical, the gas lift valve will resist chemical? You have to put the valve that is designed to resist chemical. So put chemical injection. Gas lift valve is very expensive one. This is your Lamborghini actually. This Lamborghini you keep it in the garage. You only take it the weekend, you pass by girlfriend, have a tour with her, and then take her home, go home, put this Lamborghini in your garage, lock the garage. But the following day, when you go to work, you go by bicycle. Because you cannot afford the Lamborghini cost, actually, but you can afford the bicycle cost or your Hyundai 79 model. You can afford maintenance of that. Please, this is a very expensive device. Protect it and don't use it for another purpose. I'm not going into details because this is not a well intervention course. Please remember that. This is introduction to the well intervention. And due to time limitation, of course, as well. I have a question actually, which is a nice question. I have two questions. One question say, okay, let me go to this question. To do its circulation function and communication between an annulus and tubing, it should be positioned just above the pucker. We said no, one joint above the pucker. You mentioned we use wireline to jar up and jar down to get the SSD open. I was wondering if it is the same for highly deviated wells. This is a good question. Because he said, Ahmed, use jar up or jar down, but what about high deviated wells? الواير line, general, whatever it is, a slick line or braided line or electric line. When we run it in the hole, we run with gravity. But that's why when we start having very high deviated wells and horizontal wells, you cannot use a wire line and slick line because there's no gravity, horizontal section and heavy. That's why in high deviated wells, sometimes we use coil tubing for this jarring up and jarring down, because wireline will not help you in that. So this is a good question. Thank you for asking this question. So we use coil tubing in this case. Hackers. ممكن موبايلي؟ We need to talk about the production pack. This is the third device, which is isolation device. Isolation device, we said it is package. In this drawing you have in front of you, the yellow one is the production tubing, the gray color is the casing, the blue color is the packer, which make the seal. Two types of production packer we have. We have permanent packer, this one, and we have retrievable packer. This is the retrievable packer. Both are the same. Mainly they are three elements. The yellow part, which is the body, the green part, which is the slips that bites on the casing to hold this packer in place, and the black part, which is the packer, which is the rubber element that make the seal. If you decide to run permanent packer, this one, then we run it. You have two ways to run it with. You run it with the production tubing, with the drill pipe. So you connect it to the drill pipe and you keep running till you reach the depth. Then you set it hydraulically. When you run this packer, you run it with its tail pipe that contains a landing nipple that you run a plug, you put it below the packer, and then you apply pressure from above inside the tubing, till you reach the pressure that shear the setting pins, where when you shear the pins, the slips will bite on the casing. The rubber element, due to temperature, will inflate and make seal to the casing, and now you set the packer. Now you set it hydraulically, or you can set it electrically, not with the drill pipe, but with the E-line, electric line. So you have it, you have the packer with its tail pipe, running tool with E-line. You keep running in the hole till you reach the desired depths. Then from the surface, you push the buttons. This will have nitrogen explosives that you will shear the pins. When pins are sheared, same thing will happen. Slips will bite in the casing, element will inflate, packer is set. In this case, you set it electrically. So a permanent packer, if you decide to run a permanent packer, you run it independently. You run it before you run production. And you can set it hydraulically by drill pipe, and then apply pressure from inside. Or you can set it electrically, where you run it with E-line, electric line, till you reach the desired depths. You push the bottoms, shear pins will shear, rubber element will inflate, slips will bite, Parker is set. Once you set this type of Parker, it became integral part of the casing. The only way you retrieve it back is by milling. By milling the upper part, this upper part, you have to mill it. And sometimes you have to mill the whole Parker to get it out. The only way to retrieve by milling. Once you set the Parker, you start running the completion. When you run the completion, what you will have, this is your Parker, you set it down, then you start running the completion in the hole. The last part of the completion, we call it tubing seal assembly. The tubing seal assembly is a pipe with a lot of external seals. So when you run, this tubing seal assembly will enter the Parker, the bore of the Parker. This moment we call it sting in. The sting in is the time that the moment the Parker, the tubing seal assembly, enter the Parker. Now the completion is one piece. And this tubing seal assembly, when you run it, do you run it till it reaches the top of the Parker? Well, you go inside the Parker till the middle and you stop, or you go all the way down the stroke. So under this question, we have to wait a few days because it's 6:30 already. Next session, which is number 6, we will continue talking about the Parker. We still have some time to talk about the Parkers. So we'll talk about the Parkers. This will be Sunday, 3 o'clock local time. We will talk about the Parker and then continue about the rest of the items of the completion. So we will finish completion next course, definitely. But remember that we stop at the permanent Parker this week. I will see you Sunday, inshallah. Hope. Let me see if you have any question before I move, before I go out. Thank you. Let me see if any questions. There is no more question. Dr. Ahmed, I am done.
Engineer Ahmed, thank you very much. You did amazing job as usual. Please enjoy the North Coast, and we'll see you Sunday at.
Inshallah.